Welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about Syn and Anti Hydroxylation reactions. So this is in accordance with NAP syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime, and help to learn others. So this is the syllabus, Major 2, Minor 2 paper, Fundamentals of Organic Chemistry. So let's talk about Syn and Anti Hydroxylation reactions. So let's first discuss the Syn hydroxylation reaction. So you start with one alkene. So you use cold dilute alkaline KMnO4. So that is known as Bayer's reagent. So as a result, you get this cis diol, or you can call it this Syn addition reaction or Syn hydroxylation reaction. So let's talk about the mechanism. So KMnO4, it is a ionic compound. It simply ionizes to give rise to K plus and MnO4 minus. And this is the structure of a KMnO4. K plus, O minus, and Mn has double bond O, and double bond O. So this is the structure of KMnO4. So this alkene will add in syn fashion on to this MnO4 minus. So this pi bond will attack to this oxygen. This pi bond will break on this manganese, and this double bond will attack to this alkene. So as a result, you will have a 3 plus 2 cycloaddition reaction giving rise to this manganese ester. So once you get this manganese ester, so OH minus ion in the reaction medium will act as a nucleophile. So it will undergo nucleophilic addition. So it will attack to the manganese, and this double bond will break on this oxygen. So as a result, you end up with this species. So when this O minus will come back, this MnO bond will break on this oxygen. So here the breaking of this cyclic intermediate taking place. So here as a result we get this species. So here again the proton transfer reaction takes place. So this O minus will take this proton from here. So as a result you get this hydroxyl group here, and once you get this species, when this O minus will come back, this MnO bond will break on this oxygen. So as a result you get this oxyanion, and it will take the proton from hydronium ion H3O plus. So as a result you end up with this cis diol. Similarly, another Syn hydroxylation is reaction of alkene with osmium tetroxide. You get this cis diol, or you can call it the Syn hydroxylation reaction. So again it will undergo 3 plus 2 cycloaddition reaction, and this is the structure of osmium tetroxide. OH double bond O, double bond O, double bond O, double bond O. So it will undergo 3 plus 2 cycloaddition reaction. This pi bond will attack to this oxygen, and this double bond will break on this osmium, and this pi bond will attack to this alkene. So as a result you get this osmate ester, and it will hydrolyze in presence of H plus and water. So this oxygen lone pair will take the proton from hydronium ion. So HO bond will break on this O plus. So as a result, you end up with this protonated species. And again, water lone pair will act as nucleophile. As a result, this osmium oxygen bond will break on this O plus. So as a result, you end up with this species. Again, this oxygen lone pair will take this proton, and this OH bond will break on this O plus. So as a result, you end up with this species or intermediate. Again, water lone pair will act as a nucleophile. It will attack the osmium center, and this osmium oxygen bond will break on this O plus. So as a result, you get this cis diol. Then another cis hydroxylation reaction is Woodward reaction. So alkene react with silver acetate and iodine in presence of water, giving rise to cis diol. So here it will undergo electrophilic addition reaction with the iodine. So iodine lone pair will attack here, and this pi bond will attack to this iodine, and this I bond will break on this iodine. So as a result, we end up with this iodinium ion. And we have in the reaction medium silver acetate, so OSC minus will act as nucleophile. It will attack to this carbon, and this carbon iodine bond will break on this I plus. So as a result, you end up with this intermediate. So once you get this, so oxygen lone pair here will attack to this carbon, and here you will have an enantiomeric assistance by silver plus. So this iodine will be eliminated. So it will undergo ring closure reaction. Again you will end up with this intermediate, and water lone pair will attack to this carbocation center. So as a result, again you have this intermediate, and oxygen lone pair here will take this proton, and this OH bond will break on this O plus. So as a result, you get this protonated species here. So when this oxygen lone pair will come back, this carbon oxygen will bond will break on this O plus. So you end up with this hydroxyl derivative. So here again loss of proton takes place and giving rise to this acetate. And again water will act as nucleophile. It will attack to this carbonyl carbon, and this CO bond will break on this oxygen. So as a result, you end up with this Syn diol. Now let's talk about anti-hydroxylation. So this alkene react with 4 acid RCO3H and H plus water, giving rise to anti-dihydroxylation. So here one will be above the plane. So this one above the plane, and this dotted line is below the plane. So what happens? This alkene react with 4 acid. So this alkene will attack to this oxygen, and this O bond will break on this oxygen. So as a result, you end up with this species. So oxygen lone pair will attack to this carbocation center here. So as a result, you end up with this three-membered compound here. So once you get this O plus here, so RCO minus will take the proton, and this OH bond will break on O plus. So as a result, you end up with this epoxide and carboxylic acid. So again water in the reaction medium. So water oxygen lone pair will act as nucleophile, and this CO bond will break on this oxygen, and this O minus here will take this proton. So you end up with this protonated species here, and again loss of proton from here, you will end up with this anti-diol. Similarly, you can have another reaction. You react with, take an alkene, and you react with KHSO5 and acetone. So you end up with this epoxide, and in presence of OH minus and water, you will get this dihydroxylation. So this is the mechanism. So acetone, this is the structure of acetone. So oxygen lone pair will attack to this oxygen, and oxygen lone pair will attack to this double bond here. And this oxygen bond will come back here, and this double bond will take this proton. So you end up with generating DMDO, dimethyl dioxyran. That is called a Murray reagent, and KHSO4. So now what happens? The alkene react with this DMDO, that is Murray reagent. So pi bond will attack to this oxygen, and this oxygen bond will break on this oxygen. So as a result, you end up with this species. So here the oxygen lone pair will attack to this carbocation center. So you end up with this three-membered system here. So when this O minus will come back, this CO bond will break on O plus. So as a result, you end up with this epoxide and acetone. So again in the reaction medium we have OH minus ion. So oxygen lone OH minus ion will attack to this carbon center here, and this CO bond will break on this oxygen. So as a result, you end up with this oxyanion, and this oxyanion will take the proton from water, and it will regenerate OH minus ion. So this HOH bond will break. So you will get this OH minus ion, and you generate anti-diol. The next reaction is the Prevost reaction. So alkene react with iodine and silver acetate in presence of carbon tetrachloride and sodium acetate. So you will end up with anti-hydroxylation. So here the alkene undergoes electrophilic addition reactions with iodine. So iodine lone pair will attack to this carbon, and this pi bond will attack to this iodine, and this I bond will break on this I, so it gives I minus. So you end up with this iodinium ion, and in the reaction medium we have OSC minus ion. OSC minus ion will attack to this carbon center, and this Ci bond will break on this I plus. So as a result, you end up with this species. So here the ring opening reaction takes place, and this is SN2 type. And again here the ring closure reaction takes place. So oxygen lone pair will come here, and this pi bond of a carbonyl will attack to this carbon center. And here you will have enzymatic assistance by silver plus ion. So this iodine will be eliminated. So you end up with this intermediate. So again OSC minus will attack to this carbon, and this CO bond will break on this O plus. So you end up with this species, and here the reaction is SN2 type ring opening. And upon hydrolysis, you will end up with this anti-dihydroxylation product. So please subscribe to our channel Chemistry Live UGPG. So for class 11th and 12th students, Foundation, this is the channel Foundation Chemistry AB. So this is a simple step towards e-learning, making life better. Thank you all for learning.